Alrighty, welcome back everyone. And in today's video, we are just going to cover the 2019 AP Microeconomics free response questions. So let me just share that with you to give you, just to see what it's like. So we're going to start off with question 1, then move to question 2 and 3. So why don't we get straight into it? So I'm going to pull up the questions on OneNote and we're going to do them together. Alrighty, so here's problem 1, right? Um, just a few notes here. You only have 50 minutes to answer all of the 3 questions if you decide to do it in person. Okay, so question 1, assume or as the only gas station in a small town, Philip has a local monopoly on the sale of gasoline. So Philip currently is earning positive economic profit. Just give me a second. Perfect. Positive economic profit. So let me highlight the fact that it is a monopoly and it's earning positive economic profit. Question 1A is asking us, draw a correctly labeled graph for Philip and show each of the following. Profit maximizing quantity, labeled QF, price as PF, deadweight loss, and zero economic profit. All right, so why don't we get straight into that? Oops. And let's draw out the graph. So pretty straightforward stuff. So maybe it's better if I could maybe do it right here on the right-hand side. Oops. Let's do a nice graph here. Nice line. Okay, we want to have price on the y-axis, quantity on the x-axis. Let's start off with the demand curve. Let's actually make it a little like that. Marginal revenue curve, make sure it intersects the x-axis. Then we're going to draw our marginal cost curve. Okay. And so let's start off with AI. So the profit maximizing quantity will be where MR is equal to MC, which is right here. Let's call that B. And it's labeled at QF. So the price won't be at B, it would be up on the demand curve. So let's call that PF. Okay. And we want to show deadweight loss. Okay, so that's going to be triangle A, B, C. So if we zoom in a bit here, it's this little triangle that's formed between A, B, and C. Okay, so let me just color that in. Say that's deadweight loss. Okay, so let's say this is deadweight loss. Loss of efficiency. At C, price is equal to marginal cost. This is where a perfectly competitive industry would produce at. And as we can see, there is more production and lower price. So with a monopoly, prices are higher and there's a lower amount of production. And as a result, we get deadweight loss. Again, a loss of efficiency. The other part to this question is positive economic profit. So that depends on where your ATC is located. And we have to make sure the ATC is below the price. So I'll show you an example. I'm going to use blue. Let's use blue to draw the ATC. There you go. Yeah, it's not that bad, but it could be better. So why don't I do this? There you go, ATC. And why is it earning economic profit? Because the price, PF, at QF production, so QF, it charges a price in the market, PF. But what is the average total cost at QF? Well, we translate that point on the average total cost curve, which in red will be right here. So if I horizontally translate that to the y-axis, we can see, oh, no, not cool. Right, we can see that the average total cost is right around here, but I don't think it's really asking you to do that. It's asking you deadweight loss, the maximum quantity at which Philip would earn zero economic profit. So kind of misread the question there. So zero economic profit. This will occur where the profit equation, which is price minus average total cost times quantity, is equal to zero. So price and average total cost have to be the same. So maximum quantity at which Philip would earn zero economic profit, we have to label that as QZ. Sorry, just a little hiccup on my computer. Perfect. Okay. Am I even sharing? Just want to make sure. Okay. So where that is going to occur is where price is equal to average total cost. Well, where can we find that? Which is right here on the average total cost curve. It's kind of hard to see already. So just going to do that, which is right here. Okay. And so, it's the points are really kind of close to each other, but we just want to label that as QZ, right? So where price is equal to average total cost, profit is zero. So we finish that. I think what's the breakdown here? 1 point, 4 points in total. Okay, so this question is worth out of 9 points. Part A is 5 points. So I'm guessing what's the breakdown here? I'll upload the scoring guidelines so you can check it out. Let's move on to B. Assume that Philip's fixed cost increases because of a new lease on its property, and Philip stays in business. Will each of the following increase, decrease, or remain unchanged at Philip's profit maximizing quantity? So the deadweight loss. Does deadweight loss change? No. So, where can I write it? Maybe right here, BI. So deadweight loss, I'm a bit lazy here. Deadweight loss does not change because for deadweight loss to change, right? The area, how does it change? Well, the location of the marginal cost has to change. And so because marginal cost, right? If marginal costs were to increase or decrease, it would change the optimal allocation of what quantity would be produced at in a perfectly competitive market. And so fixed cost does not change marginal cost, right? So we would say deadweight loss does not change because fixed cost do not affect marginal cost. And maybe this is kind of overstepping, but it's not too bad. And okay. So marginal cost will determine the optimal allocative efficient quantity in the market. So wherever price or demand intersects marginal cost, then that intersection will determine allocative efficiency. So any deviation away from it will change efficiencies. And so since monopolies are inefficient in the sense that they don't price the good at marginal cost, there is deadweight loss. So because marginal cost is not changing, then deadweight loss is not changing. So what would happen to Philip's profit? Well, it's pretty obvious that Philip's profit would decrease. So for two, oh, there's a stay home at order, in fact, decrease. Why? Why would it decrease? Well, ATC is comprised of average fixed cost and average variable cost. So if your fixed cost rises, average fixed cost rises as well, which would increase ATC. This question is not asking you to explain, but if it were, you would say something like that. Part C, assume the demand for gasoline decreases, but people were bike to work, bike to work more often. Honestly, biking is key, right? Good health, save money, good for the environment. Anyways, oh gosh. C, what happens? What must be true for Philip to continue to operate in the short run? Well, this is the shutdown criteria, right? So price has to be greater or equal to average variable cost. Well, first of all, at uh okay, price has to be greater or equal to average variable cost. Why? Because if your price is lower than your average variable cost at the production, at the profit maximizing production, then the price that you sell the product does not cover your, usually it's your labor cost. So think of it as you hire a worker, an additional worker, and he or she only brings in one hamburger, right? The price of one hamburger an hour, but you pay this worker $14, an additional $14, which is your additional variable cost, right? And so uh, clearly that's not very efficient because you're losing money. And so if the price is lower than your average variable cost, then essentially you're not making enough money to cover at least your labor costs or your variable costs. And then you still have to worry about your fixed costs. Whereas if you were to shut down, you wouldn't have to pay the variable cost. You would just pay the fixed cost. So you need to know the average variable cost, or price has to be greater. Holy, I'm winded. But I do cardio, which I'm going to do right after this. What happens to profit maximizing quantity and price in the short run, assuming the firm continues to operate? Both will decrease. It's pretty obvious, although it might not be obvious, but let's explain. You don't have to explain why. But you know, what's going to happen is if demand changes, this changes marginal revenue, right? So let me just erase all this stuff here on the graph, just to give you a, let's erase the whole thing actually. So I'll give you, I'll show you illustrative example. Right, it's not part of the question. So let's keep the marginal cost the same. And in red will be the shift of the demand curve, okay? So demand is going to shift to the left, let's say due to lower demand. And because of that, marginal revenue is going to shift, right? So previously, A was the old profit maximizing quantity, right? But now, because of the demand shift, the new profit maximizing quantity is here at Q2. Oops, is at Q2. And I guess I didn't really draw. Oh yeah, let's make it a bit smaller. Wait, what did I do? There. Oops. There. There we go. And so as we can see, prices is lower and quantities lower. I kind of messed up the initial demand shift because essentially I didn't really scale it properly, meaning that if I were to use that previous D2 curve, the price would be higher, and that's not the case. So that is question one. Let's move on to question two. Okay. Question two, we've done this question a few times, I think. I'm not too sure. We've done variations of it. The following table is a table showing Dana's marginal benefit and of purchasing water bottles and good X. Okay. What is Dana's total benefit from purchasing 2 bottles of water and one, well, hiccups. So let's do that here. I think I have a bit of space. So 2 bottles of water, what's the total benefit? Well, 2 bottles of water gives her a benefit of 24 plus 18. And then 1 bottle of good X gives her 24. Okay. So when you do some pretty intense math, you get $66. Okay. Let's move on to B. Assume the price of the good of X is $5. Calculate the total surplus of consuming 3 units of X. Well, 3 units of X, you get 24 plus 18 plus 12, right? Well, consumer surplus is your willingness to pay minus the price paid, okay? And so her willingness to pay is her marginal benefit. Because if her marginal benefit is 24, let's say for first bottle, then she's willing to pay at most $24 for it, nothing greater. If let's say the price was 25, but the marginal benefit of her water is 24, then the person doesn't buy it. So anyways, to calculate consumer surplus, what I'm going to do is I'm going to take the total benefits, which is 24 plus 18 plus 12 minus the total cost or the price paid, which is 5 times 3. And so you're going to get, hold on. You're going to get 24 plus 18, which is 36. So 54 minus 15, then you get $39. Cool. Part C. That's how you do it. Straightforward. Now assume the price of bottle of water is $3 and the price of the unit of good X is $6. Dana spends her entire budget of $30 of water and good X. Explain why Dana does not maximize her benefit when she purchases 2 bottles of water and 4 units of X. So 4 units of X is $6. So 4 times 6 is 24. So she exhausts her income. But let's see here. So for the 4th bottle of water, it's going to be 6, okay, divided by, so what I'm doing is I'm going to compare the margin utility of X over the price of X, and I'm going to compare that to the margin utility of, let's say, water over the price of water. So PW stands for price of water and margin utility W stands for margin utility of water. So the MUX over the price of X. So she consumes 4X. Her margin utility is 6. What's the price? 6 versus the margin utility of 2 bottles of water, which is 18 versus the price, which is $3. So what we're seeing here is if we break it down, for $1, the margin utility for X that she gains is just 1 versus 18 divided by 3, which is 6, right? So for every $1, Dana gets a marginal benefit of 6 or marginal utility of 6, right? So what this means is this person, Dana, should reallocate her consumption away from water and more on good X. Wait. I think I messed it up here. Good X is $6. Okay. So, oh, yeah, I mean, she should consume less of good X and more of water, right? Because 24 to, yeah, that's right. Because water, again, per $1, she gets 6 marginal benefits or 6 marginal utilities. So this is not efficient. Is it asking us to explain? Yeah. So you would say Dana should spend less on good X because her marginal utility per dollar is lower than water. Something along the lines of that. So that's C. Let's move on to C to CII. What is the optimal consumption? Wait, what are the optimal quantities of good X and good Y? So let's actually do that. I'm going to calculate the MUX over the price of X. So what I'm going to do is divide the margin utility divided by price. So 24 divided by 6 is 4. Well, 18 divided by 3 is 18 divided by 6 is 3. 2, 1, 1/2. Okay. Now I'm going to do the exact same thing, but for water. So 24 divided by 3, that's going to be, well, math. 8, 6, 12 divided by 3 is 4. This is 2, 1. Okay, so what is the optimal combination? So if I'm Dana, I have $30. What should I spend my first $3 on? Well, I'm going to choose the good with the highest marginal utility per dollar. I'm going to choose water because that provides me a better value than good X. I'm going to buy the second water because 6 is greater than 4. I'm going to buy the third water and the first X because the margin utility is the same. You're probably thinking, oh, maybe I should stop here because they're equal. No, you want to continue to consume until your budget is exhausted. So I'm going to buy the second X. Okay. Then how much money have I spent already? Well, 6, 12. So I spent $12 on good X. I've spent 3, 6, 9. $9 on good water. So 12 plus 9 is 21. I have $9 left. You know what I'm going to do? I'm going to buy the fourth water, and then I'm going to buy the third X. That exhausts my income. So now I'm going to say the optimal quantity is 4 waters and 3 good X. And without even calculating the total surplus, you've actually maximized total surplus when you do this. So part 3, this one is a bit tricky. So suppose the price of good X drops to $3. So now it's much cheaper. Now we have to recalculate the optimal quantity. Actually, what's it asking? It's asking to calculate Dana's cross price elasticity of demand for water respect to good X. State whether the two goods are substitutes. Show your work. Okay, so EX, cross price elasticity. So I'm going to observe the percentage change. I'm using the midpoint because it's a bit shorter. So I'm going to do the percent change of So we're looking at the relation. Okay, so percent change in quantity of water. Right now, I'm observing how does the consumption of water change with respect to changes in price of X or price, yeah, price of X, right? So that's cross price elasticity. So we need to figure out the quantity change of good Y. So first of all, we need to recalculate the margin utility first of good X. So I'm going to do that here over, now it's $3. So convenient, and it's convenient because it's going to be the same margin utility as the good Y. And to kind of skip a few steps, what's going to end up happening is that Dana exhausts all her income on 5 goods of Y or good X and 5 waters. So what ended up happening here is because of this decrease in the price of X, Dana consumes 1 more good Y. So now we could actually work through our cross price elasticity equation, and we're going to do, well, what's her new consumption of good water? It's 5 minus her previous consumption, 4 divided by 4. I'm going to multiply that by 100. What's the new price of good X? Well, it's going to be 3 minus the old price, 6 divided by 6 times 100. And what we're going to get is big numbers here. We're going to get 25% over minus 50%. And you're going to get minus 0.5. And because they are negative, because the value is negative, we're going to say that the good is a complement. It's a complement. All right, so that's question 2. Obviously, part 3. So CIII depends if you were to get II correctly. So make sure you really focus on getting the first parts right. So we're going to move on to part 3 or question 3. So part 3, okay. Oh, we did this question already in game theory, but I don't mind. So, just to, no, I'll say that near the end. Okay, so PP is currently the only pizzeria in KCT. Okay, I don't need to do that. But essentially, there's 2 options, right? For Patrick Pie, he advertises or does not advertise. Then we got D's Pizzeria, DP, who either can enter or stay out. And so here we have the payoff matrix. So part A is asking, what actions maximize the combined total profits for PP and DP? Oh, so we're looking at which actions, which cell here has the highest combined payoff. So clearly, if I do some next level math, I get this, where Patrick Pie and DP advertises and stays out respectively. So what actions? So PP advertises and DP stays out. Okay. B, conditional on your response in part A, does DP or PP have an incentive to cheat on this combination? Explain using numbers. Well, DP, let's ask ourselves. So DP is currently staying out, right? We're assuming this situation. He has another choice, which is, or her, enter. If DP enters, is this a good solution? No, because DP's payoff is -2, and -2 is obviously worse than 0. So DP has no incentive because the payoff minus 2 is lower if decides to cheat. Does PP have incentive? Well, if D maintains staying out, PP, right now PP gets a payoff of 175. And if D maintains staying out, so he or she honors their response, PP could not advertise or cheat, but his payoff is 100. And so clearly that's not good. It's lower than 175. So we would say PP has no incentive because cheating leads to minus $75 payoff. I'm just getting a bit lazy there, but you would say that if PP were to cheat, his or her payoff would be 100, which is less than 175. So part C, does PP have a dominant strategy? Well, let's consider what's a dominant strategy. It's a strategy you do regardless of what the other player does. So if, let's say, DP enters, what is Patrick Pie's best response? Well, Patrick Pie is either going to advertise or does not advertise. It does not advertise has a higher payoff than advertise when DP enters. When DP decides to stay out, what's Patrick Pie's best response? Well, it's actually advertised because it's much greater than 100. So clearly PP does not have a dominant strategy. Again, to have a dominant strategy, your action does not depend on what another player does. Clearly, PP, his or her move depends on, well, it's a he because Patrick is a he name, well, depends on whether D enters or stays out. D, identify the Nash equilibrium. Well, we figured out what Patrick Pie is going to do. What is DP going to do when Patrick Pie advertises? Well, it's minus 2 versus 0. Well, DP is going to stay out when Patrick Pie advertises. What if Patrick Pie does not advertise? 15 versus 0. Well, 15 is greater than 0. So when Patrick Pie advertises, does not advertise, D's Pizzeria enters. So you would say, identify the Nash equilibrium, that there's two. PP does D. I'm getting really lazy here, so please don't do this. PP does not advertise, and so here's one, and DP enters. The second equilibrium is when PP advertises and DP stays out. So part E, ignoring antitrust considerations, suppose that PP and DP, suppose that Patrick pays D's Pizzeria $20 if D chooses to stay out. We want to redraw the matrix and identify the Nash equilibrium. So what I'm going to do here is redraw that matrix, okay? I'm going to do it right here. I'll do it right here, actually. So we're going to have enter, stay out, and we're going to have advertise, and DNA does not advertise. And then we're going to have PP. Then we're going to have DP. Okay. So if these values don't change, hold on, but the values when DP stays out change. So what's going to end up happening is if DP decide to stay out, what's it? Suppose that Patrick Pie pays $20. Okay, so in order for DP to stay out, Patrick Pie is going to pay $20. So his payoff goes down to 155 because 175 minus 20, but DP gains $20. So if Patrick Pie does not advertise, his payoff is going to be 80 to pay DP 20, right? Okay, so we have to recalculate the new Nash equilibrium. So let's say I'm PP and DP enters, right? DP enters. Oops. If DP enters, I am going to, as PP, I'm going to DNA. I'm not going to advertise because 150 is greater than 50. If DP stays out, well, I'm PP, right? Am I going to advertise or DNA? Well, advertising has a better payout, 155 versus 80. So now we switch roles. What if I'm DP and PP decides to advertise? Well, I'm going to stay out. 20 is greater than minus 5. If PP does DNA, am I going to stay out or enter? Well, stay out gives me a benefit of 20. Enter gives me a payoff of 15. Well, clearly, staying out is better. So in our case here, DP actually has a dominant strategy, and it's to always stay out only if Patrick Pie pays DP $20. So the Nash equilibrium is here. DP stays out and PP advertises. And there you have it. That is the problem, problem set number 3. If you have any specific problems or multiple choice that you want me to go over in video format, I could do it. Just send me a message via email or Google Classroom. So I think game theory and consumer utility are big topics. So, most likely this will be on the main, the actual AP exam. I feel like those are big concepts. As well as externalities is big, and obviously the market structure and factor markets. So that's pretty much it for this video. If you have any questions, please let me know.